Right now, above our heads and far beyond what the human eye can see, the universe is unleashing a storm of power so vast it makes everything we've ever built on Earth looking significant. Imagine two stars, each heavier than our sun, spinning in a deadly dance and about to collide with a force so strong it will ripple through the very fabric of space-time. In less than a second, they will release more energy than our galaxy produces in an entire year, sending out gravitational waves that literally stretch and squeeze the universe itself. But here's the shocking part. That's not even the most violent event happening out there. Lightning, the rawest force we experience on Earth, is only the tiniest spark compared to what unfolds in deep space. One bolt carries billions of volts, heats the air 5 times hotter than the sun's surface, and strikes the planet over 8 million times a day. That's staggering power for something we consider ordinary, but on the cosmic scale, it barely qualifies as a warm-up act. If lightning can kill, burn, and terrify us so easily, what does it mean when we realize that our sun can unleash storms powerful enough to cripple all technology on Earth? Solar flares and coronal mass ejections launch billions of tons of plasma into space at millions of miles per hour. If a storm like the Carrington Event of 1859 hit today, planes would fall from the sky, satellites would fry, the internet would vanish, and cities would go dark in minutes. Civilization itself could unravel, not in decades, not in years, but in a single day, and yet the sun is considered calm compared to other stars. Out there, some stars live fast, die young, and explode in cataclysms that make solar storms look like firecrackers. A supernova can outshine a galaxy of billions of stars, tearing itself apart in seconds, hurling elements like iron, gold, and uranium into space elements that would one day become the bones, blood, and breath of life itself. Every ring of gold on a human finger, every drop of iron in our blood, every breath of oxygen we inhale was forged in the heart of one of these violent stellar deaths. But even a supernova is just the middle of the story. When the most massive stars collapse, they don't just die, they give birth to monsters. Neutron stars, objects so dense a teaspoon weighs billions of tons. Magnetars, with magnetic fields so powerful they could erase your credit card from halfway across the moon. Pulsars, spinning hundreds of times per second, firing beams of radiation that sweep across the galaxy like cosmic lighthouses. And when two of these collide, the resulting kilonova creates more gold in seconds than all of Earth's minds combined could ever produce. The universe doesn't just show off its power, it writes its history in violence. From lightning storms on Earth to the death of stars and the collision of galaxies, every explosion, every burst of energy, every eruption of force is part of the same chain that led to us sitting here, looking up at the sky, wondering where we came from and what comes next. The truth is, the universe doesn't hold back. It doesn't ask for permission. It creates, destroys, and rebuilds on scales that are impossible for the human mind to fully comprehend. And yet we try, we observe, we measure, we tell stories, because deep down we know that the more we understand about these explosions, storms, and collisions, the more we understand about ourselves. A bolt of lightning tears through the sky with a blinding flash, and in that single instant, nature reminds us just how small we are. That strike isn't just a bright light or a loud bang. It's the universe flexing its muscles right here on Earth. One bolt of lightning can carry up to 5 billion volts of electricity. It heats the surrounding air to 50,000 degrees Fahrenheit, which is 5 times hotter than the surface of the sun. The thunder that follows isn't just a noise. It's the sound of air exploding, a shockwave ripping through the atmosphere as superheated gases expand faster than the speed of sound itself. And all of this happens in less than 1,000th of a second. It's over before you can even process what you just saw. Yet in that blink of time, enough energy was released to power an average American home for an entire month. Think about that. One random strike from a storm cloud could keep your lights on, run your appliances, and charge your phone for weeks. That's the kind of raw, concentrated power lightning carries every single day, and Earth experiences more than 8 million strikes daily. Multiply that by a year, and the numbers become almost impossible to imagine. So, how does nature pull this off? The answer begins high above, in storm clouds that stretch miles into the sky. Picture the atmosphere as a massive battery constantly charging itself. Inside those towering thunderheads, water droplets and tiny ice particles collide billions of times. Each collision strips away tiny bits of electrical charge, slowly separating positive and negative particles. The top of the cloud becomes overwhelmingly positive, while the bottom fills with negative charge. Meanwhile, the ground below the cloud builds up a positive charge of its own, almost as if it's waiting for the storm to notice it. The difference in charge grows larger and larger, like a rubber band being stretched tighter and tighter. Eventually, something has to give. When the electrical tension becomes too much for the air to contain, the storm finds a pathway to release it. That's when a lightning bolt is born. But here's the twist. It doesn't strike in one direction. The bolt we see is actually electricity racing both ways at once. A nearly invisible leader stroke creeps downward from the cloud, searching for the easiest path through the air. At the same time, invisible positive streamers rise up from tall objects on the ground, reaching for the cloud. When the two connect, an immense return stroke rockets back upward toward the sky at 1/3 the speed of light, creating the brilliant flash we see. Some bolts stretch for over 100 miles. Others hit the exact same spot multiple times in rapid succession, giving the eerie flickering effect we sometimes witness. And then there are the outliers, the monsters. The strongest lightning ever recorded carried more than 300,000 amps of current. For perspective, the outlet you use to charge your phone carries about 15. Imagine the same kind of current running through your wall, multiplied 20,000 times. Lightning may be terrifying, but it isn't only destructive. Every strike plays a role in keeping life on Earth alive. The intense heat and energy of lightning split nitrogen molecules in the atmosphere, allowing them to bond with oxygen and create compounds that fertilize soil. Carried down by rain, these compounds enrich the ground, making it possible for plants to thrive. Without lightning, vast ecosystems would collapse from a lack of essential nutrients. In that sense, lightning isn't just a symbol of destruction, it's also one of creation. It's both a killer and a provider, shaping life on Earth in ways we often overlook. And yet, for all its power, lightning is still just a glimpse of what nature can do. On Earth, it is the king of storms, feared and respected. But when we look up at the sun, we realize lightning is nothing more than a spark compared to the storms our star can unleash. If a single bolt can fry power lines and ignite forests, what happens when an entire star decides to let loose? That's when we step beyond weather, beyond storms, into the realm of solar fury, and what comes next makes lightning look like a child's game. If lightning is the Earth showing off its power, then solar storms are the sun reminding us who is really in charge. Our star looks calm from 93 million miles away, a steady golden disk rising and setting without fail. But beneath that calm surface is a boiling ocean of plasma, a constant storm of charged particles churning in magnetic fields, so powerful they can twist and snap like rubber bands stretched too far. And when those magnetic fields break, the sun erupts with a force that makes every lightning strike on Earth look like a spark from static electricity. These eruptions are called solar flares and coronal mass ejections, and when they're aimed at Earth, they can disrupt our entire civilization in an instant. A solar flare is like the sun's version of a lightning bolt. Except instead of striking one city, it floods space with a burst of radiation that can cover planets. Temperatures inside a flare can soar to tens of millions of degrees, hurling high-energy particles and X-rays outward at nearly the speed of light. But even that isn't the sun's most terrifying weapon. That title belongs to the coronal mass ejection, or CME. Picture 1 billion tons of the sun's outer atmosphere suddenly being blasted into space, moving at millions of miles per hour. These ejections can stretch larger than entire planets, and when they slam into Earth's magnetic field, the results can be beautiful and devastating. The auroras we admire at the poles, shimmering curtains of green and purple light, are actually the visible signature of solar storms. Charged particles from the sun slam into Earth's atmosphere, colliding with oxygen and nitrogen molecules, exciting them into glowing. But while the light shows are breathtaking, the unseen effects are far more dangerous. Solar storms can fry satellites, knock out GPS systems, disrupt airline communications, and in the most extreme cases, collapse entire power grids. Imagine waking up one morning and finding that the internet is gone, satellites are silent, flights are grounded, and cities across continents are plunged into darkness. That isn't science fiction, it's exactly what happened in 1859 during an event known as the Carrington Event. Back then, the world didn't rely on satellites or smartphones, but telegraph operators reported sparks flying from their equipment, some receiving shocks, and telegraph paper bursting into flames. The auroras were so bright that people in the Caribbean thought the morning sun had risen early. Now think about what would happen if a storm like that hit today. In a world completely dependent on technology, experts estimate it could cause trillions of dollars in damage, knocking out power for months or even years in some regions. Hospitals, communication systems, financial markets, everything could grind to a halt. The sun, the very source of life on Earth, also holds the power to send us back centuries in a single day. And here's the unsettling part. We've already had a close call. In July 2012, a massive CME erupted from the sun, racing through space at more than 4 million miles per hour. If Earth had been just 9 days further along in its orbit, that storm would have slammed into us head-on. NASA scientists later admitted that it could have been catastrophic, knocking out modern infrastructure across the globe. Instead, it missed us, a cosmic near-miss that few people even knew had happened. But as frightening as solar storms sound, they also serve as a reminder that the sun isn't unusual. Stars across the galaxy unleash storms far greater than anything our sun has ever produced. Some stars blast away their outer layers entirely, creating winds that strip neighboring planets bare. Others rotate so fast and build up so much magnetic energy that their eruptions dwarf anything we've ever observed, producing stellar flares that make our sun look like a candle flame. Solar storms are terrifying, but they're only the beginning of the cosmic violence we're about to encounter. Because when a star reaches the end of its life, its death is unlike anything else in the universe. And compared to that, even the worst solar storm seems almost gentle. When the sun erupts in a solar storm, it's enough to terrify us here on Earth, but the truth is our star is a relatively quiet neighbor. Out there in the galaxy, other stars live much more dangerous lives, and their deaths are spectacles of destruction on a scale almost beyond imagination. When a massive star burns through its fuel, it doesn't simply fade away, it detonates in one of the most powerful explosions the universe has ever devised, a supernova. These cosmic blasts are so bright they can outshine entire galaxies of billions of stars for weeks at a time. In a single moment, a star that has been burning for millions of years tears itself apart, hurling its outer layers into space at tens of thousands of miles per second, while its core collapses under the crushing weight of gravity. The numbers alone are staggering. A supernova releases more energy in 10 seconds than our sun will in its entire 10 billion year lifetime. It is the ultimate finale, a death so violent that it reshapes everything around it. But here's the twist. Supernovas aren't just acts of destruction, they are also acts of creation. Inside the core of a massive star, fusion builds heavier and heavier elements, from hydrogen and helium up to iron. But when the star collapses and explodes, the violence creates conditions where even heavier elements are forged in an instant. Gold, platinum, uranium, and countless other elements essential to planets, technology, and even life are created in the heart of these explosions and scattered across the galaxy. Every piece of jewelry, every circuit, and even the iron flowing through our blood once came from the violent death of a star. Without supernovas, life as we know it simply wouldn't exist. Supernovas are powerful enough, but when the biggest stars in the universe reach their end, they don't stop there. Instead, they collapse into explosions so extreme they've earned their own name: hypernovas. A hypernova is like a supernova on steroids. These occur in stars that are dozens or even hundreds of times larger than the Sun, and when they collapse, the energy released is 10 to 100 times greater than a normal supernova. Hypernovas often unleash powerful jets of plasma that blast outward at nearly the speed of light, drilling through the dying star's outer layers and releasing gamma-ray bursts, the most energetic explosions known in the universe. A gamma-ray burst can release more energy in a few seconds than the Sun will in its entire life, and if one happened close enough to Earth and pointed in our direction, it could strip away the ozone layer and trigger a mass extinction. Thankfully, the closest known gamma-ray burst candidate is far enough away not to pose a threat, but the possibility is a chilling reminder of the violence lurking in the universe. Astronomers have seen hypernovas from across billions of light years, their brightness so extreme they shine through the depths of cosmic history. In fact, some of the most distant objects we can observe are the afterglows of ancient hypernovas, explosions that lit up the young universe when galaxies were still forming. These colossal deaths don't just scatter elements and energy, they reshape their surroundings. The shock waves from supernovas and hypernovas sweep through interstellar space, compressing clouds of gas and triggering the birth of new stars. In this way, the death of one star becomes the seed for countless others, continuing the endless cycle of destruction and creation. For all their brilliance, supernovas and hypernovas are also deeply mysterious. Scientists are still working to understand exactly what triggers the explosion and how the collapse transforms into a detonation powerful enough to rival an entire galaxy. Some theories suggest that in the most massive stars, the collapse creates a black hole at the core, and the energy released in those final seconds comes from material spiraling into that abyss, unleashing forces far greater than we can replicate in any laboratory. So, when you look up at the night sky and see a peaceful blanket of stars, remember that at any moment one of them could be preparing for its final act. Somewhere out there, a star is swelling, collapsing, and ready to explode, and when it does, the light from that event will travel across space for millions of years, eventually reaching us as a sudden new star blazing in the sky. And while the thought of a cosmic explosion so powerful might be terrifying, it's also humbling, because without these violent deaths, the universe would be nothing but gas and dust. It is through destruction that creation is made possible, but as violent as supernovas and hypernovas are, they are not the end of the story, because sometimes the core of a star survives the blast, and what it leaves behind is something even stranger and even more powerful. When a massive star explodes in a supernova, the brilliance of the blast may fade after weeks or months, but the story of its death doesn't always end there. Sometimes, what's left behind is even more fascinating, more bizarre, and in many ways more terrifying than the explosion itself. The collapsing core of the star can be squeezed so tightly by gravity that atoms themselves break apart, leaving behind one of the strangest objects in the universe, a neutron star. Imagine taking the mass of the sun and compressing it into a sphere, only about 12 miles across. Smaller than a city. The density is beyond comprehension. A single teaspoon of neutron star material would weigh billions of tons, as heavy as a mountain compressed into the palm of your hand. The surface gravity is so extreme that if you dropped a paperclip from just a few feet above, it would hit the surface at thousands of miles per hour. But neutron stars don't just sit quietly in space. Many of them spin at incredible speeds, rotating dozens or even hundreds of times per second. As they spin, their powerful magnetic fields funnel charged particles into beams of radiation that shoot out from their poles. When those beams sweep past Earth, we see them as rhythmic pulses of light and radio waves. That's why they're called pulsars, cosmic lighthouses ticking away with such precision that they keep time more accurately than atomic clocks. These objects are so extreme that the fastest known pulsars spin more than 700 times per second, their surfaces moving at nearly a fifth the speed of light. The regularity of their signals was so shocking when first discovered that scientists briefly wondered if they were receiving transmissions from alien civilizations. And then there are magnetars, the most magnetic objects ever found in the universe. A magnetar is a type of neutron star with a magnetic field so powerful it could erase your credit card from halfway to the moon. To put it in perspective, Earth's magnetic field keeps our compasses working and shields us from solar radiation. A magnetar's field is trillions of times stronger. It's so intense that it can literally distort the shapes of atoms themselves, stretching them into thin, needle-like forms. When these magnetic fields shift or crack the neutron star's crust, the result is a starquake, releasing more energy in a fraction of a second than the sun produces in 100,000 years. These bursts are so powerful that they can blind satellites, disrupt Earth's atmosphere, and flood our planet with X-rays and gamma rays even from tens of thousands of light years away. If a magnetar were closer, it could sterilize entire worlds with a single outburst. Despite their terrifying power, neutron stars also play a creative role in the universe. The collisions of two neutron stars produce kilonovas, cosmic explosions that not only release gravitational waves, ripples in space-time itself, but also forge enormous quantities of heavy elements like gold and platinum. In a few seconds, these mergers can create more precious metals than all the mines on Earth could produce in human history. Every piece of gold jewelry, every bit of platinum in technology, was born in the crushing embrace of colliding stellar corpses. Neutron stars, pulsars, and magnetars are reminders of how violent and creative the universe can be at the same time. They're relics of death that become engines of energy, sending out radiation across space, shaping galaxies, and even seeding new worlds with the elements of life. Yet, even these bizarre remnants are not the final word in cosmic destruction. Because sometimes, when a star is massive enough, even neutron degeneracy, the quantum force that resists collapse, can't hold back gravity. In those cases, the core falls further, deeper, until nothing can stop it, not even light. And that is where the story of black holes begins. When a star is massive enough, even the collapse into a neutron star isn't the final chapter. Gravity keeps pushing, crushing matter beyond anything our minds can fully comprehend. At a certain point, no force in the universe can resist that collapse. Not the repulsion between atomic nuclei, not even the quantum pressure that holds up neutron stars. The core implodes further, and what emerges is the most terrifying object in existence, a black hole. A black hole is not just a star remnant. It is a place where gravity becomes so intense that space and time themselves break down. Imagine compressing several times the mass of our sun into a point so small it has no surface, no physical edge, only a boundary called the event horizon. Cross that boundary and nothing, not even light traveling at 18,600 miles per second, can ever escape. From the outside, the black hole is invisible, a hole in the fabric of reality itself. What makes black holes even more unsettling is the way they warp the universe around them. Time itself slows to a crawl near the event horizon. If you watched someone fall in, you'd see them slow down, moving slower and slower until they appeared frozen just above the edge. But from their perspective, they would fall through in seconds, never realizing the outside world saw them stop. This strange stretching of time isn't just theory, it's a fundamental prediction of Einstein's relativity, and it's been confirmed by observation. Black holes bend space like a funhouse mirror, distorting the light of stars behind them and creating eerie rings and arcs that astronomers call gravitational lensing. But black holes are more than just traps for light. When matter falls toward them, it doesn't simply disappear. It heats up, forming a spinning accretion disk that blazes hotter than almost anything else in the universe. Friction and magnetic forces within the disk accelerate particles to near light speeds, blasting out jets of radiation and plasma that can extend for thousands of light years. These jets are so powerful they can regulate the birth of stars across entire galaxies, effectively acting as cosmic engines that shape the universe on the largest scales. In fact, the black hole at the center of the Milky Way, Sagittarius A, weighs about 4 million times the mass of the Sun, and though it's quiet now, it has the potential to unleash forces that could outshine every star in our galaxy combined. Even smaller black holes, the stellar mass ones formed from collapsing stars, are no less deadly. If one wandered into our solar system, it wouldn't even need to touch Earth to destroy us. Its gravity would rip apart the orbits of the planets, fling worlds into interstellar space, and stretch Earth into a stream of debris in a process scientists call spaghettification. This isn't just a colorful metaphor. Near a black hole, gravity pulls so much harder on your feet than your head that you'd literally be stretched into a thin strand of atoms long before you reached the center. Yet, as horrifying as black holes sound, they also represent one of the universe's greatest mysteries. What happens inside? At the center of every black hole lies what physicists call a singularity, a point of infinite density where the known laws of physics break down. Our equations can't describe it. Space and time fold in ways that defy understanding. Some theories suggest that black holes might be gateways to other universes, or that their cores could somehow connect to the fabric of space-time itself. Others believe they may hold the answers to uniting quantum mechanics and general relativity, the two great but incomplete pillars of modern physics. What we do know is that black holes are not rare. The universe is littered with them, from the millions of stellar mass black holes scattered across galaxies to the supermassive ones anchoring galactic cores. And yet, they are still only the middle chapter in the story of cosmic violence. Because while black holes consume everything that comes too close, galaxies themselves sometimes become the stage for even grander events, when entire star systems and worlds collide. And in those collisions, the universe reaches its next chapter of unimaginable power. Black holes may be the most terrifying single objects in the universe, But when it comes to true cosmic-scale destruction, nothing compares to what happens when entire galaxies collide. From our quiet view on Earth, the night sky looks calm, the stars fixed in place like diamonds on velvet. But in reality, galaxies are constantly moving, drawn together by the invisible pull of gravity in a cosmic dance that can last billions of years. And when two galaxies finally meet, the result is one of the most spectacular and violent events in the universe: a galactic collision. These collisions don't unfold in moments or days, but across millions of years, slow-motion cataclysms that reshape star systems, rip apart worlds, and create bursts of new life from chaos. Imagine two massive spirals, each containing hundreds of billions of stars, approaching each other at speeds of millions of miles per hour. As they collide, their delicate arms stretch and twist like cosmic taffy, flinging stars into intergalactic space and distorting both galaxies into strange, tangled shapes. The incredible thing is that while the event is violent on a galactic scale, individual stars almost never collide. The distances between them are simply too vast. Instead, the true violence happens in the clouds of gas and dust that make up the galaxies. These clouds crash into each other head-on, compressing and triggering furious waves of star formation. Suddenly, thousands of new stars ignite in what astronomers call starburst galaxies, systems that shine with brilliant newborn light while their chaotic interiors churn with radiation and explosions. These newborn stars live fast and die young, burning through their fuel in just a few million years before exploding as supernovas, enriching their surroundings with heavy elements. In this way, galactic collisions are both destructive and creative, tearing apart old structures while giving birth to new stars, planets, and perhaps even life. Our own galaxy is not immune. In about 4.5 billion years, the Milky Way will collide with our nearest large neighbor, the Andromeda Galaxy. The two spirals are already rushing toward each other at more than 250,000 miles per hour, and when they meet, the night sky will light up with a view unlike anything humanity has ever seen. Over time, the two galaxies will merge into one enormous elliptical system, and though Earth's fate is uncertain, the odds are high that our solar system will be flung into a completely new orbit, cast adrift in a galaxy that looks nothing like the one we know. For future observers, if any exist, the sky will glow with countless new stars, and the view will be both breathtaking and alien. At the heart of these collisions, the supermassive black holes anchoring each galaxy are drawn inexorably toward one another. As the galaxies merge, their central black holes begin a deadly spiral, orbiting closer and closer while losing energy in the form of gravitational waves, ripples in space-time itself. When they finally collide, the energy released will be greater than that of every star in the galaxy combined, sending gravitational shock waves pulsing through the universe, waves strong enough that even here on Earth, billions of years later, sensitive detectors could feel the tremors of that ancient event. These black hole mergers are among the loudest events in the universe, not in sound, but in gravity. Galactic collisions are not rare. They have been happening since the earliest days of the cosmos. And in fact, they are one of the main engines driving galactic evolution. Many of the giant elliptical galaxies we see today are the remnants of ancient collisions, their shapes smoothed and rounded by countless mergers over billions of years. Some of the most beautiful structures in the universe, from long tidal streams of stars to vast arcs of glowing gas, are scars left behind by these titanic encounters. Yet as spectacular as these collisions are, they are still not the ultimate expression of cosmic violence. Because even galaxies, with all their billions of stars, are only pieces of an even larger puzzle. And when entire clusters of galaxies crash together, the scale of destruction grows beyond comprehension, revealing forces that reshape the very structure of the universe itself. If the collision of two galaxies is one of the most dramatic sights in the cosmos, then what happens when hundreds or even thousands of galaxies collide together is almost too vast to imagine. On the grandest scales, galaxies don't float alone. They gather into clusters bound together by the invisible glue of dark matter, and sometimes these clusters crash into each other in events that unleash forces so extreme they defy comprehension. These are not slow spirals like the dance between the Milky Way and Andromeda. These are titanic collisions of entire clusters, galaxies upon galaxies, slamming together at millions of miles per hour, dragging with them vast oceans of hot gas, webs of dark matter, and the supermassive black holes at their cores. The aftermath is a cosmic battlefield, glowing with shockwaves, arcs of X-ray light, and gravitational distortions that reveal just how violent the universe can become. The most famous example is known as the Bullet Cluster, where two galaxy clusters smashed through each other about 3.8 billion light-years away. What astronomers observed was breathtaking. The galaxies themselves passed mostly unharmed, just as stars do during galactic collisions. But the clouds of gas in each cluster slammed together head-on, heating up to hundreds of millions of degrees and glowing brilliantly in X-ray light. Even more astonishing was what the collision revealed about dark matter. The gas slowed and clumped, but the invisible halos of dark matter that make up most of the cluster's mass sailed straight through each other, leaving the galaxies surrounded by massive, unseen cocoons. It was one of the most striking pieces of evidence ever discovered that dark matter is real and plays a central role in the architecture of the universe. In the chaos of destruction, nature had exposed one of its deepest secrets. But galaxy cluster collisions aren't just about gas and dark matter. They also set the stage for some of the most energetic particle accelerators in the cosmos. As shockwaves ripple through the hot plasma, they hurl particles to incredible speeds, creating cosmic rays with energies millions of times greater than anything human technology can produce. These particles race across intergalactic space, some eventually slamming into Earth's atmosphere, where they shower down as invisible messengers from catastrophic events billions of light-years away. In a sense, every time we detect one of these cosmic rays, we are catching a piece of energy from a cosmic war zone larger than entire galaxies. The violence doesn't end there. When two clusters merge, their central supermassive black holes are pulled toward each other, eventually spiraling together just as galaxies do, but on an even larger scale. These mergers unleash gravitational waves so immense that they ripple across the universe, stretching and squeezing space itself like the surface of a cosmic drum. Each wave carries the memory of that collision, a signal of destruction and creation traveling unhindered through the fabric of space-time until it reaches our detectors here on Earth. These signals are more than just noise. They are proof that the universe itself is alive with movement, with unseen cataclysms shaking the very skeleton of reality. Cluster collisions are also architects of cosmic structure. The shockwaves and turbulence stir up the intergalactic medium, shaping how gas cools and where new galaxies can form. Entire regions of space can be stripped bare, while others are compressed into dense knots that ignite with new generations of stars. In this way, destruction and creation are once again locked together. The violence that tears clusters apart is the same force that sows the seeds of new galaxies, new solar systems, and perhaps even new life. It's humbling to realize that even on scales this vast, the universe isn't finished showing us what it can do. Because as titanic as cluster collisions are, they are still just fragments of a much larger design. Beyond the galaxies and clusters lies something even greater, the cosmic web, an immense network of dark matter and galaxies stretching across the entire universe. And it is within that web that we see the true skeleton of creation itself, the grandest stage where destruction and creation play out in ways that make even the collision of clusters look small. When we zoom out beyond stars, beyond galaxies and even beyond the collisions of galaxy clusters, we start to see something that changes our entire perspective of the universe. On the largest scales, space is not random or scattered. It is woven together into a vast network called the cosmic web, a structure so immense that it stretches across the entire observable universe. Picture billions of galaxies arranged like glowing beads on invisible threads of dark matter, forming bridges, nodes, and filaments that span hundreds of millions of light years. This is the true skeleton of the cosmos, a structure shaped not only by the pull of gravity, but also by the mysterious force of dark matter, which outweighs all visible matter by a factor of 5. It is here, in this grand lattice of creation, that the most powerful processes in existence reveal themselves. The cosmic web is a place of constant motion. Galaxies stream along its filaments, pulled inexorably toward intersections where matter piles up to form massive clusters. When these clusters collide, the shock waves ripple through the filaments, stirring up plasma and accelerating particles to unimaginable speeds. But even more dramatic is the role dark energy plays in shaping this vast network. While gravity tries to pull matter together, dark energy, the strange force causing the expansion of the universe to accelerate, is relentlessly pushing everything apart. On small scales, galaxies and clusters can form and collide, but on the scale of the cosmic web, the filaments themselves are slowly being stretched, thinned, and pulled away from one another. Over billions of years, this tug-of-war between gravity and dark energy is literally rewriting the architecture of the universe. For us, living in a galaxy that is just one speck on one filament of this immense structure, the scale is almost impossible to grasp. A single filament can span 500 million light-years, carrying thousands of galaxies, each with billions of stars. The nodes where these filaments meet are the densest and most active regions of the universe, teeming with black holes, galaxy mergers, and powerful radiation. Yet, between the filaments are cosmic voids, vast expanses of near-empty space, stretching hundreds of millions of light-years across, where galaxies are rare and the night is infinitely darker. These voids are expanding faster than the filaments themselves, hollowing out the universe like bubbles in an ever-growing foam. What's most extraordinary is that the cosmic web may hold the answers to some of the deepest mysteries in physics. The way galaxies move along filaments reveals clues about the nature of dark matter. The way voids expand offers insight into the behavior of dark energy, and the collisions at the nodes are natural laboratories for forces so extreme we could never hope to reproduce them on Earth. Even the gravitational waves we've only just begun to detect ripple through this web, carrying messages from cataclysms billions of years old. In a sense, the cosmic web is not just the framework of the universe, it's the stage upon which the greatest stories of creation and destruction are written. And the story isn't finished. As dark energy continues to accelerate cosmic expansion, the web itself will change. In the far future, filaments may stretch so far apart that galaxies become forever isolated from one another, locked inside their local groups with no way to reach beyond. To future civilizations, the universe may look empty, stripped of the connections that once revealed its true scale. The cosmic web we see today is temporary, a fleeting pattern in the life of the cosmos, and we just happen to be alive at the perfect moment to witness it. From lightning bolts that split the sky, to neutron stars crushing matter, to black holes consuming worlds, and now to the cosmic web stretching across all of existence, each scale of power tells us the same truth. The universe is not still, not safe, and certainly not simple. It is alive with motion, destruction, and creation. And as we study the cosmic web, we are not just mapping galaxies, we are tracing the very blueprint of reality itself. From the moment we opened with lightning tearing through the sky to the unimaginable violence of neutron stars colliding, black holes devouring matter, galaxies slamming together, and the cosmic web stretching across the observable universe, one truth has become undeniable. The universe is not calm, and it is not still. It is a place of endless chaos and creation, a stage where destruction itself fuels the birth of stars, planets, and life. Every terrifying force we've explored is not just a spectacle, it is part of the great cycle that made us. The gold in your ring was forged in a neutron star collision. The oxygen in your lungs was built in the core of a massive star before it exploded. The atoms in your body were once trapped in ancient processes of fusion, collapse, and fire. We are not just bystanders to this violence, we are its living legacy. And yet, the deeper we look, the more humbling the story becomes. The lightning storms of Earth that once seemed fierce now feel like sparks compared to the fury of the sun. The sun itself seems fragile compared to the detonation of supernovas, and even supernovas are dwarfed by hypernovas and gamma-ray bursts that release more energy in seconds than stars will produce in billions of years. Then come the black holes, swallowing light and time itself, and beyond them, entire galaxies colliding in slow-motion avalanches of gravity. Each layer reveals not an end, but another beginning. Forces so vast that every time we think we've reached the peak of cosmic power, the universe shows us something even greater. But this escalating scale is not just about violence, it's also about connection. The stars that collapse into black holes leave behind the heavy elements that make planets fertile. Galaxy collisions may rip systems apart, but they also trigger the birth of new stars. Even the largest collisions, when entire clusters crash together, expose the hidden scaffolding of dark matter that underpins all of existence. And when we zoom out further, the cosmic web emerges, not chaos, but order. An elegant network connecting galaxies across billions of light years. This web is not static, it is dynamic, shaped by the constant tension between gravity and dark energy. It is the canvas upon which the story of the universe is still being painted. We live in a fragile moment caught between past and future. Billions of years of cosmic violence have already written the chapter that made us, and billions more await to decide what becomes of the universe itself. Someday, Andromeda will collide with the Milky Way, and the night sky will blaze with unfamiliar light. Someday, distant civilizations, if they exist, may witness black holes colliding, sending ripples of gravity across the cosmic web. And someday, dark energy may stretch the filaments so far apart that galaxies are forever isolated, and the universe fades into darkness. But right now, we stand at a crossroads where the past and future are both visible, where the universe still reveals its most powerful events, and where we have just begun to understand that everything we see is part of a single connected story. That is the true revelation of these cataclysms. They are not random disasters in a cold, indifferent void. They are the gears of a machine far larger than we can comprehend, mechanisms of both death and rebirth, destruction and creation. Without them, there would be no stars, no planets, no life, no us. The same violence that seems so terrifying is also the force that gave us everything we cherish. It is a reminder that we are not separate from the cosmos. We are woven from it. Every atom in our bodies is a survivor of cosmic wars fought long before Earth even existed. And so, the next time you look up at the night sky, remember, those tiny points of light are not peaceful. They are the visible remnants of titanic battles, of ancient stars that lived and died, of galaxies that collided, and of a universe that is still evolving. To witness the universe is to witness both creation and destruction intertwined. And the greatest power of all may not be the black holes or the gamma ray bursts, but the simple truth that out of all this chaos, the universe found a way to become aware of itself through us. We are not just looking at the story of cosmic violence, we are part of it.